Hello, welcome to today's quick Quake briefing webinar on the South Carolina earthquake swarm of this year. My name is Elizabeth Angel. I'm EERI's Communications and Program Manager. And I just wanted to welcome you to EERI in this webinar. And if you're not familiar with us, to tell you a few words about EERI. The Earthquake Engineering Research Institute is the leading nonprofit organization connecting professionals and researchers from a wide range of disciplines, working together to advance earthquake resilience around the world. And if you want to learn more about us, we'll share some more information at the end, but we are excited to bring you this webinar from our Northern California chapter, and I'm going to turn it over to the Northern California chapter president, Volkan Sevilgen, to talk about that.
I would like to welcome everyone for the webinar that is so important. It's often not often overlooked area in southern South Carolina. And we would like to remind everyone that we have a chapter in Northern California that dedicated to reducing earthquake risks. And now we are starting another chapter. Hopefully there's an initiative to start their own chapter in South Carolina. And here are the information how you can potentially contribute or join that chapter. To introduce the speakers, I would like to introduce Bruce Mason, who is our Secretary and Treasurer. Bruce?
Thank you very much. I'd like to welcome everyone to our briefing on the South Carolina earthquake swarm. My name is Bruce Mason. I'm a member of the executive board of the Northern California chapter. I'd like to talk a little bit with regard to getting on the announcement list. Our webinars are intended to be free and open to everybody. They are announced in the newsletter Pulse that's issued by EERI. And also, if you're a member of the Northern California chapter, you will receive email announcements. However, if you're not a member but want to get announcements, please send me your email address as shown here. Also, and I want to mention that we have all of our webinars are on YouTube, and so you can be able to view them at a later date. Now, on to today's webinar. South Carolina is experiencing a long swarm of earthquakes. They started last December with a magnitude 3.3, and they continue today. I've just checked the website, and I believe there was a 2.1 magnitude that occurred just today in South Carolina. These earthquakes are relatively small, being less than magnitude 4, but several of the largest in this swarm is the largest earthquake South Carolina has experienced in nearly 10 years. Today we have two speakers. The first will be talking about seismological aspects of South Carolina and with regard to this particular swarm. And our second speaker today will talk about emergency preparedness and response in South Carolina. So the format for today's program is it'll be a 60-minute program. Each speaker will talk for about 20 minutes. Then the remaining time we will have for question and answers. And how we'll do that is we encourage questions from the audience. And how you will do that is you will click the Q&A button that you see at the bottom of your screen. Then you'll type in a question. Then Volkan will compile the questions. And then he will come back later in the program and he will present the questions to our speakers. Now, we are aware that we might have more questions than we have time. So each of our speakers today have kindly will put their email. We have their email addresses listed here, and you can be able to send them your questions in the coming days. Now, what I'd like to do is introduce our first speaker, Stephen Jamais, and he will be talking about seismology. He's a professor of geology at the College of Charleston. Let's warmly welcome Stephen. Stephen, please proceed.
Thank you. Let me get going here. I'm Dr. Stephen Jamais. I'm at the College of Charleston, Department of Geology and Environmental Geosciences, in which we have what we call the Low Country Hazard Center. The low country is basically the coastal part of South Carolina. So the Low Country Hazard Center covers not just earthquakes that we have here, but particularly things like flooding, hurricanes, sea level rise, and the other hazards that occur in our area. So the starting slide here, you're actually seeing the original building of the College of Charleston, which actually survived the magnitude 7 1886 earthquake, but with still clearly visible damage. And if you ever come to Charleston, look me up and I will give you one of our guided earthquake walking tours of Charleston if you want to see the impact of that earthquake, which you can still see in the architecture of the city from 1886. So today, the things I'm going to talk about, some general things about, why we get, where earthquakes occur, and why we get them in South Carolina. Spend a good bit of time looking specifically at this swarm near the towns of Elgin and Lugoff, South Carolina, and try to talk a little bit about the potential mechanism for the length of the swarm. I can tell you, talking with folks from the epicentral area, they're getting kind of tired and they keep asking me when these earthquakes are going to stop. So first slide here, just basically taking the past 20 years or so since 2000, earthquake epicenters as located by the USGS in South Carolina and vicinity. Most of the earthquakes in the state tend to be down here near Charleston. So I've outlined this area with many epicenters. This is the source zone of the magnitude 7 1886 earthquake, and it's still the most common place to have earthquakes in South Carolina. In terms of larger earthquakes over the past 20 years or so, about 20 years ago, I think 20 years in next month, there was a magnitude 4 earthquake actually off the coast. There's actually a coastal fault system called the Helena Banks Fault System offshore. And what we call the Midlands of South Carolina. About 8 years ago, there was a magnitude 4.1 earthquake. And as mentioned just today, it was actually up here in the northwestern part of the state. Just earlier this morning, there was a magnitude 2.1 earthquake. But as you see, you have earthquakes pretty much well scattered throughout the state. Plus there's some, obviously down into Georgia and up into North Carolina outside of the state. What's unusual about these earthquakes near Elgin is that if you were to tell me, say last year this time we were going to have another earthquake swarm, I would have actually picked the Monticello Reservoir. I don't know if anyone knows Pradeep Telwani. He was a seismologist at the University of South Carolina, retired a few years ago, has done a lot of work on reservoir-induced seismicity. And there are a couple of places, most common being Monticello here, where we tend to get earthquake swarms in South Carolina. So kind of pulling up a map, zooming in closer, most of the swarms that we get are these reservoir-induced seismicity. This particular map here, you see the outline of the reservoir, you see the asterisks of the epicenters. This is actually a swarm that occurred in the mid to late 1990s. That this comes from a paper in 2001 centered under the reservoir. When the reservoir was impounded in 1977, there were actually thousands of these, largest magnitude 2.8, covering a somewhat larger area. And just as recently as last year, there was a small swarm of about 25 to 30 events centered on the east side of the reservoir that occurred, again, related to this Monticello Reservoir. And just to let you know, the reason why the reservoir is there is that's where one of our nuclear power stations is on the southern side of the reservoir there. So again, this is where I would expect to find swarms in South Carolina. But of course, we wound up getting a swarm in a very different area. There's a map zoomed in on the epicenters. As of this morning, there were 75 events associated with this swarm, the most recent one being on Monday. Now, these are the locatable events. There are also smaller events we see only on the closest station, probably a factor of 2 to 3 above these numbers that are occurring in this area. It started, as Bruce mentioned, with a magnitude 3.3 on December 27th. And there have been to date 5 earthquakes above 3, the largest of which was a 3.6 back in late June. So first point I want to make, swarms themselves are not unusual in South Carolina, but the location here is somewhat unusual. This is not where we normally see swarms. We normally see them associated with the state's reservoirs, right? Now, the focal mechanisms for these events indicate that they're occurring on primarily either reverse or oblique reverse faults. So the larger events, we can do focal mechanisms. The initial event on December 27th is mainly a reverse fault. The subsequent magnitude 3+ events, I think only 3 of the 4 actually have mechanisms. We tend to get these oblique reverse mechanisms. Now, the p-axis, notice the pressure axis on the beach ball diagrams here are approximately the same position. So if we compile all that information together, and this actually comes from Bob Herman at St. Louis University Earthquake Center, who compiles focal mechanism information for North America and other places, particularly for these more moderate and small size events. You see in the blue bars are the p-axes for compression axes for reverse fault events, the blue, green, or oblique reverse, and they're all pretty much line up in the same direction, right? So there's a very consistent, roughly east-northeast, west-southwest compression direction across South Carolina and locally into Georgia. In fact, people may be interested in this event that's down into Georgia on this map. That was actually a magnitude 3.9 earlier this year that actually created a little bit of lateral spreading damage. So if you want to know about that, please let me know later. I can tell you more. But when we look at the Elgin earthquake swarm, where it is occurring, unfortunately, so this map here was made by Scott Howard, the director of the South Carolina Geological Survey. Oops, go back. The pink, more or less straightish lines are what's called the Eastern Piedmont Fault System. There's also a wavy line here, which is, I don't know why he kept it in the same color, which is the boundary of the exposed Paleozoic rocks of the upstate versus the Cretaceous and younger sediments of the coastal plain. So this Eastern Piedmont Fault System, it actually runs all the way from Alabama up into Virginia, tends to be along this boundary between these older exposed rocks of the interior versus the younger sediments of the coastal plain. In fact, most of these are actually imaged by aeromagnetic data. And one thing we first noticed, both from the mechanisms and from the orientation of the epicenters of the swarm, is that it does not appear to be on any of these main faults of the Eastern Piedmont Fault System, which, when you look at the stress field, the maximum compression direction, being nearly parallel to the fault strike, you would not expect those faults to be reactivated. What appears to be happening is that there's what Scott is calling a cross fault between 2 of the major strands of the Eastern Piedmont Fault System, which is oriented to move in the current stress field. So the earthquakes are occurring on a smaller fault within this larger fault system. This also tends to be helpful to us when talking to emergency management folks and other local population and state officials, is we would not expect a very large earthquake out of this swarm. It does appear to be on a fairly short fault segment, so it's not likely to produce anything particularly large in magnitude. Now, of course, being a lot of engineers here, you probably want to see some accelegrams from these earthquakes. One thing about the seismic network in South Carolina is that compared to what you're probably used to there in California, it's relatively sparse, right? The squares here are the seismometer stations, generally broadband seismometers. Some will have accelerometers with them. When this swarm started, these 3, the 2 blue ones and the brown one there, were the three closest stations, and only a few days later did the University of South Carolina folks put in an accelerometer very close to the events where these events are occurring. So since basically the first of the year, we do have one station in very close. Of course, notice most of the seismometers are down near Charleston. That's where we typically have most of our earthquakes. And also not on this map, I am currently running a 17-element microseismic network for a couple of years, or about a little past a year of that experiment, to try to focus more on what structures are moving under the coastal plain down here. So again, this isn't a place we typically expect earthquakes, so we didn't really have a close-in station. In fact, the Monticello Reservoir Station, that reservoir is right here, right? When that swarm started, we had a close-in station right from the beginning because we kind of expected the seismicity to occur there, right? And here, show a few accelerograms. The closest station, which is that new one, Barn, which is literally in a barn at a horse farm, at a distance typically of 5 kilometers or less to these events. This is the largest event in the swarm. Oh, I forgot to put the date. It was June 29th, but I just put the time for some reason. On the east-west channel, we had greater than 30% G. But then the problem is, the next closest stations, you get out to tens of kilometers, right? And you can see we have recordings out to well over 100 kilometers. But again, we really only have one station in close, not counting a citizen science Raspberry Shake seismometer, which was installed back in April. That's also fairly close, but that doesn't have an accelerometer with it. And this is getting a lot of press here in South Carolina. These larger events that have occurred are resulting in 3,000 or more felt reports with the USGS Did You Feel It system. Even small events, say around magnitude 1.5, are typically felt by a number of people, and they'll get maybe up to a dozen reports of those. And the felt area also includes the state capital of Columbia, so there's lots and lots of interest in these events, particularly when we get to larger events that are pretty widely felt throughout the middle parts of South Carolina. And finally, the sort of last part here is kind of why are they occurring, particularly why are we having a very long-lived, well over 6-month earthquake swarm now? So far, the only real hypothesis I've seen comes from Pradeep Tawani, who's, again, a specialist in reservoir-induced seismicity. And he pointed out to me, actually, a paper in Geophysical Journal International from what they call a hydroseismicity earthquake swarm in Bohemia, where if you get heavy rainfall in a particular valley, a fault-controlled valley, the fault itself has high permeability. You get basically a groundwater pressure pulse down to seismogenic depths. You get a burst of earthquakes maybe a week or so after the heavy rainfall, and it's appears that's a pore fluid pressure effects at depth, but that there's a hydraulic connection to shallow groundwater systems. So what Pradeep is hypothesizing is that very first earthquake, which they do appear to be pretty shallow within the top 3 kilometers, essentially opened up a crack system and allowed shallow groundwater from the coastal plain sediments to seep down to these seismogenic depths. And then further events are kind of expanding that fracture network, and that's kind of lubricating the faults and keeping things going. The big downside of this hypothesis is the really way you would want to kind of double check it is looking at water levels in nearby water wells. And as far as myself and Scott Howard, the state geologists, have been looking, we can't find any in that particular area that might give us a clue whether or not this actually means anything. Now, I do actually have some of the environmental folks are looking for me now, see if they have some other wells they know about. But right now, this is kind of an untestable hypothesis as to why we're getting a swarm. away from a reservoir where we do know we have pore fluid pressure effects that are helping create these swarms. So hopefully I didn't go too fast or too slow. So previously, we mostly see swarms basically associated with the state's reservoirs. This is unusual in location for that reason. However, the focal mechanisms of this earthquake swarm are consistent with the regional stress fields in South Carolina. So there's not anything going on unusual in that aspect. It's just that the earthquakes are larger than we see typically for these swarms. And then a hypothesis that perhaps there's a new connection between shallow groundwater and a deeper fracture network that is creating a pore fluid pressure pulse that's helping keeping this swarm going. And I guess they're going to be getting questions from other people, but
yes. Okay. Stephen, I'd like to thank you for a very informative lecture. I learned a lot. Being on the West Coast here, we all know about the great 1886 earthquake in Charleston, but we really don't know much about the other earthquakes that occur there in these swarms. So this was very informative, and I learned a lot from your presentation today. And with regard to questions, of course, as I mentioned previously, we'll handle those at the end. What I would like to do now is move on to our second speaker. Our second speaker is Brian Blake. He is with the Central United States Earthquake Consortium. And he will be talking about a little bit about the consortium, introducing us to it, but also he'll be talking about earthquake preparedness and response in South Carolina. So let's warmly welcome Brian. Brian, could you please proceed?
Yeah, thanks. Can you see my screen okay?
Looks good.
Okay, thanks. Thanks for having me, Bruce, and thanks for the invitation. It's a pleasure to be here with everyone. As mentioned, my name's Brian Blake, and I'm the Associate Director with the Central United States Earthquake Consortium. And I'm going to talk a little bit about South Carolina's earthquake program and things that the South Carolina Emergency Management Division does. To note, I'm not with the South Carolina Emergency Management Division, but I work closely with them, as well as groups like College of Charleston and Dr. Jaume and others within the state and the region in the central and eastern U.S. on earthquake hazards. So I will go over just a few areas. First, just a review of South Carolina's earthquake program and their earthquake planning response procedures, some activities that they're undertaking in the upcoming year, and then also looking at how FEMA Region 4 intends to support earthquake response in South Carolina. So again, I'm not with South Carolina Emergency Management Division. Their earthquake program manager, his name Ken Struble, he was unable to be here today, so he asked me to pinch hit for him. And I am with the Central United States Earthquake Consortium. We're a 501c3 nonprofit based in the Memphis, Tennessee area. And we work primarily in those central states and the Midwestern states that you see there in our logo. But we also work and support states in the eastern portion of the country too, South Carolina, Virginia, North Carolina, et cetera, all of whom have some level of earthquake hazard and risk. We've worked with them over a long period of time. So our primary focus, as you see there in our mission, is the reduction of deaths, injuries, and property damage and the economic losses associated with earthquakes in the central U.S. Our board of directors are the state emergency management directors in each of our member states. So those are those ones you see there in the logo: Arkansas, Alabama, Illinois, Indiana, Kentucky, Missouri, Mississippi, and Tennessee. And we also have associate states, which are the states surrounding those member states. And two of those states, South Carolina and Kansas, also sit on our board of directors with voting privileges. So our board is comprised of 10 emergency management directors from around the states. And we do quite a number of activities around earthquake resilience, you could say. Everything from education and outreach to mitigation planning, to multi-state response and recovery planning, as well as working with researchers, engineers, seismologists, geologists, et cetera, and to take basically the lessons learned and apply the research that has been done towards earthquake hazard risk reduction and apply that here in the central U.S. So unlike out in California, we do have earthquakes here quite regularly in the central and in some cases the eastern U.S. We have them quite regularly, but they're not as widely or as often thought of by the general public, and may not always be feeling the earthquakes, but they are happening all the time. So just to get into kind of the presentation real quick, South Carolina Earthquakes Program activities are essentially led by the South Carolina Emergency Management Division. They are the lead coordinating organization for organizing, supporting mitigation, preparedness, planning activities within South Carolina. And they work with a number of state, regional, and national subject matter experts to do that. So they might not necessarily be subject matter experts on all of those things, but they are the coordinating entity. And that's a similar role that CUSEC takes as well. So groups like College Charleston, the Low Country Hazard Center, the South Carolina Geological Survey, the U.S. Geological Survey, FEMA, groups like CUSEC, all those various groups are who the earthquake program manager within South Carolina would coordinate with to provide kind of a well-balanced outreach, education, mitigation, preparedness, and planning program for earthquakes within the state. And South Carolina is also one of the leading states and drivers behind the Great Shakeout Earthquake Drill on the East Coast. As most of you have probably heard and probably know about, the Great Shakeout started in California more than 10 years ago now. And since it's expanded across the country, and it's even held in locations throughout the world. But on the East Coast, there's a version called the Great Southeast Shakeout, and that includes 11 or 12 states there in the southeast part of the country. And South Carolina is one of the big leaders in that, and they have been since its inception. They do a lot of work to support that activity there at EMD, the Emergency Management Division. So the vision statement for EMD's earthquake program, so they're coordinating the recognition, the understanding, communication, and planning for earthquake hazards and associated risks within South Carolina. And that's to empower the whole of community to make informed decisions on planning, preparing, responding, and recovering from earthquakes. And they have a few, actually 5 strategic goals there for their earthquake program. And that includes awareness and understanding, so public education and outreach. It's hard to do something about a hazard or a risk if the public doesn't know about it, or if elected officials don't know about it. So that's the number one goal there. And then increasing seismic or resilience to the seismic hazards through mitigation, building codes, things like that. And then coordinating and developing their planning, training, and exercise programs to be able to create mitigation plans, response plans, recovery plans, train people that need that information, and then test that out so that they can improve their plans and their training activities. Then also increasing and enhancing situational awareness and assessment for post-earthquake, which we'll talk a little bit about in a few moments, and then increasing their own internal capacity and visibility. So when there's an earthquake within South Carolina, it kind of depends on the magnitude of the earthquake as to what happens there at the state emergency management level. So for earthquakes that are under magnitude 4, they do not activate their earthquake plan, which is kind of an annex or an appendix to the South Carolina Emergency Operations Plan, the EOP. And that's kind of like an all hazards plan. And then this earthquake plan would support that. But so under a magnitude 4 within the state, there's not a whole lot that's going to go on other than they're going to document that it's happening, work with whoever the appropriate people are, and even such as USGS, College of Charleston, and the groups that are seismologists to understand what may be coming after one of those earthquakes. Between a magnitude 5 and about a 6, they'll start to kind of spin up their State Emergency Management Operations Center. And then the State Emergency Response Team will recommend to the governor to declare a state of emergency so that they can begin implementing the State Emergency Operation Plan within selected emergency support functions, which are things like infrastructure and communications, health and human services, and those sorts of things that might be impacted during a disaster. They will get those folks that need to support those functions into the State Emergency Operations Center and begin working to respond in whatever way is needed. And they'll also start creating their statewide common operating picture for situational awareness and damage assessments in the local communities in the impacted areas. So after a 6, they'll go to their OPCON level 1, which is basically the Emergency Operations Center is fully activated, and then they'll ask that the governor declare a state of emergency and then request the next step, which is a presidential disaster declaration. So this is going to be a very large earthquake event and a large earthquake response that they're planning. They'll start to roll out their agreements for mutual aid, both within South Carolina and then external to other states through the Emergency Management Assistance Compact, and that's called EMAC. And then the state and the counties will begin, they'll be working with their alternate emergency operations centers and FEMA and other groups as necessary to support the impacts there to the local government. So that's kind of my idea of what they're planning for and what they're planning to do in the event of an earthquake. Now, I should note that here in recent times, we're looking at this from if there's a magnitude X, we do this. But now it's leaning more towards an emergency management planning or an earthquake planning at the emergency management level, that you start looking at the response based on the level of ground motions in a particular area, and basing your response. So if the ground motions exceed X, then you do Y, and that's something that numerous states are looking at the guidance of USGS and FEMA and others. So one thing, or some things that they the EMD has done recently has been working closely with FEMA Region 4 on their Charleston earthquake plan and annex to the FEMA Region 4 response plan. We'll talk about that in a little detail in a few moments. They're launching an earthquake.sc microsite, and that's going to happen on October 1st, right before the Great Shakeout drill. And they've also, EMD, developed their strategic plan recently and conducted an earthquake mitigation workshop that was held in the Charleston area. And CUSEC was involved with that, as was Dr. Jamais and the College of Charleston. But that workshop was really successful, brought together 30 plus individuals from local government, nonprofits, state government, et cetera, to look at earthquake hazards, look at ways those risks could be reduced, and then provided some action items and templates that the participants could use in their own planning back in their day-to-day jobs. Upcoming activities for EMD for their earthquake program. Of course, as mentioned, the Great Shakeout is a big focus for them, and that's coming up October 20th, third Thursday in October annually at 10:20 a.m. And for those of you that aren't familiar with the Shakeout, I encourage you to go to shakeout.org and learn more about that. Millions of people that participate in that earthquake drill annually. Then they are working on earthquake plan rewrite over the next 12 to 18 months. So looking at those different levels of response and recovery activities and how they would implement those, they're looking at redoing that. Then updating the South Carolina Earthquake Guide, which is a brochure that they've published for a number of years, that's going to get a new facelift and get published in the next year. And then also, this is a project we're working with them on, is to develop a critical facility and infrastructure inventory and a multi-year plan for that. And that's going to be done using the FEMA P154 rapid visual screening procedures. A lot of you have probably heard of that, and this is very similar to the EERI's Safe Schools initiative. But this is going to be looking at multiple facility types, like fire stations, police, schools, county and city administrative buildings, emergency operations centers, et cetera. And looking at those and applying the FEMA P154 procedures, developing that inventory, and then taking that data and including it in a hazard mitigation plan. And it can also be included in response and recovery plans as well. And kind of running that data through HAZUS and so forth. So those are some things that they've got coming up there at EMD. Within the state at EMD, here's some key contacts you might want to know about. Ken Struble is the current earthquake program manager. Candace Shealy is the state hazard mitigation officer, and Derek Becker is the chief of public information and external affairs. And they're all very well tied in with earthquake program activities. Lastly, just real quick, I'll go over the FEMA Region 4 Charleston Earthquake Annex, Charleston Earthquake Response Plan, which is an annex to FEMA Region 4 and their Region 4 response plan for all hazards. And this plan looks at community lifelines, which are a new concept to FEMA, newly organized concept over the past 5 or 6 years. And the lifelines look at stabilizing 7 different areas. So you're looking at safety and security, food and water and shelter, health and medical, energy, communications, transportation, hazardous materials. And so after disaster, FEMA looks at the request, if a state requests federal assistance, what is needed to support the state and the local governments to stabilize those lifelines in those particular areas. And so this response plan addresses a lot of that. And they've been working on this over the past 12 to 18 months, I think. It's based on 2 earthquake scenarios, magnitude 7.3, which is the 1886 Charleston earthquake historical event, and then a magnitude 7.1 near Somerville. And these are afternoon earthquake scenarios that are in the summer months, not really including any kind of major tsunami threat or hazard associated with the earthquakes. So the study region for this impacts South Carolina as well as parts of Georgia and North Carolina. 3 counties in South Carolina have the most severe shaking. That's Charleston, Dorchester, and Berkeley. And just some real brief numbers on the potential impacts. More than 1.6 million households expected to be impacted, estimated 1,400 fatalities, greater than 200,000 buildings damaged in this, at least moderately damaged. And this modeling has all been done through FEMA Region 4 using the HASIS, their FEMA's HASIS loss estimation software, which a lot of you may be familiar with. So the plan has several operational phases that go through all the way from immediate response to kind of community stabilization. That's through those lifelines, and then sustaining those operations, and it leads up to long-term recovery, which is a total separate plan of itself. And like kind of with as expected with earthquakes, you could have very large aftershocks that could cause a lot of the response activities to kind of have to restart and reset. And so this plan takes into account some of that will be needed. And that's not always the case with other disasters, with hurricanes or high wind events, things like that. Usually it happens and you respond and then you start your recovery operations. But this you could be responding, starting recovery, and then have a significant aftershock that causes you to respond again. So one unique thing about this plan is it's taken into consideration what's called lines of effort planning. And that's looking at those things shown here, for instance, is a line of effort for sheltering. So it's looking at what are the things needed for that sheltering mission? What are the immediate objectives? It's kind of really breaking it down so that you get to the point where this is the end state you're looking to get to from start to finish. What are the things that unforeseen factors notwithstanding, what are the things that will get you from point A to your end state, where there, in this case, sheltering, there's no more need for assistance from the federal government for shelter. And so this plan takes into consideration lines of effort for numerous individual things like sheltering, emergency power, communications, and so forth. One new thing for this plan, and to, I think, any FEMA plans to be of interest to particularly engineers, is the structural evaluation line of effort. And we worked with FEMA, we being CUSEC, we worked with South Carolina in Region 4 to identify this, that, it's well known that after an earthquake, there are going to be potentially hundreds, if not thousands, depending on the size of the earthquake, buildings and structures that need to be looked at for safe occupancy, particularly using the Applied Technology Council ATC 20 post-earthquake safety evaluation procedures. And FEMA, although they offer training for this, for ATC 20 through their National Earthquake Technical Assistance Program that's led by ATC, they offer that, but but they have not really included this in their regional plans and their response plans. And safety evaluation and structural evaluation is somewhat of a response initiative, because it's not search and rescue. It's a recovery activity. It's not necessarily response, because it's not like search and rescue where they're going in there and trying to find people, get them out of rubble and so forth. This is more looking at whether or not homes, critical facilities, buildings, et cetera, are safe to occupy. And so we worked with them on this to integrate this into the plan to what are the things needed for the engineers and architects that might be needed to come in and support this structural evaluation line of effort. And so that's really a kind of a first time that this thing had been done with one of the FEMA response plans in this way. And so that's been really good. And so South Carolina is kind of a model citizen, if you will, for this activity. Then, so the lead for this Charleston earthquake plan is Jessica Gibson. If you're interested in finding more about that, you can email her there. She's based in Region 4, and she's the official in charge of that response plan. And she works closely with Noriko Kibble, who is the FEMA Region 4 earthquake program manager, who also works closely with South Carolina, which is within FEMA Region 4. Here are some links for you to South Carolina Emergency Management Division, their website. They got a bunch of neat resources, information on earthquake hazards and so forth, along with the State Geological Survey, who has hazard maps and information on that earthquake monitoring, like Dr. Jaume was mentioning. Of course, recommend you connect with him as well for more details on that. Here at CUSEC, we have a number of maps, information products that you might be interested on earthquakes that are occurring here in the central U.S., not only within South Carolina, but without. All throughout our region, we have earthquakes just about every day. We have lots of information on that on our website and that link that you see there. Just would like to thank everyone for being here, especially to EMD and Dr. Jaume at College of Charleston, as well, FEMA and partners at the National Earthquake Hazards Reduction Program. There's my contact information. And Bruce, thanks again for having me, and everyone for participating today. I'll be happy to answer any questions.
Thank you so much, Brian. Your talk, it was very informative. I had no idea of all the things that's happening back east. And personally, I'd never heard of the Great Shakeout. I think in the future, after October, we might have a briefing that have the results from the drill that you're going to have in October. This was very informative for me.
Yeah, thanks.
Okay, very good. I'd like to move right along here and move into the Q&A portion of today's meeting. So I'd like to turn control of the meeting over to Vulcan to pose questions to our speakers. Vulcan, can you please proceed?
Thank you, Bruce, and thank you, Stephen and Brian. These two presentations were very informative and very interesting. My first question to Stephen. You have shown us the ground motion plot, the acceleration plot, and one thing was very striking. You showed 0.3 G.
Yes.
So did you verify that? That seems very high for magnitude 3.5.
Yeah, we had a bit of a discussion about that. So the instrument itself was installed by Phil Crotwell, University of South Carolina. He's kind of the tech who helps operate the network. And several of us went over, and it does seem to be correct.
That's amazing.
Yeah. Now, of course, it's a very short duration for those really high accelerations, but so far I can't find anything wrong with that's being done. So, yeah, again, when I was looking at that myself, I had the exact same response. It's like, all right, is the correct information. And as far as we can tell, yes, it is.
Also, it potentially explains why so many people felt this relatively tiny earthquake for California standards.
Also remember, attenuation is quite different here. And these also are shallow events. Most of them come in less than 4 kilometers deep, even these larger ones. So they're pretty close to the surface. The attenuation is very low, so it doesn't attenuate very much before getting there. So you do get these sort of higher accelerations at short distances. And the sediments there, I think only 50 meters of coastal plain sediment, roughly above basement. So we're not very different. Like when I'm down here at the low country, we don't get high accelerations because we have upwards to 1 kilometer of coastal plain sediments, which really filter out those high frequencies. But we also get a lot of resonance, right? So we have more, not the absolute accelerations aren't very high, but they'll just keep going. So it's a very different, it's not quite a hard rock site there, but it's almost a hard rock site.
Fascinating. Did you observe any damages to anything around it?
Well, I haven't been there personally, but from social media reports, if anybody wants a little bit of humor with their emergency management folks, follow the South Carolina Emergency Management Division on like Facebook and Twitter. But some of the responses to their stuff, so I've seen people talk about cracks in walls, things displaced off of shelves, sort of about intensity 6 level damage. So no structural damage, but, something noticeable in a number of cases. Again, for those larger 3+ events and very localized.
Fascinating. Brian, I have a question for you. You have shown us essentially how you are responding to emergency situations and how you prepare, how the state is prepared for any sort of situation like that. Is there anything else that you think that California is doing and South Carolina isn't doing yet? I think you are mute.
Yep,
mute.
sorry. Well, not being based in California, I don't have a lot of knowledge of that sort of thing. One thing, though, like within South Carolina, I know there are quite a number of unreinforced masonry buildings and older vulnerable structures that were built before earthquake codes became, very prevalent. And so that's one thing they're doing right now, is to try and catalog those and identify where those particular vulnerabilities might be. And then they can start to do things that they might address them. A number of those buildings, though, are very historic structures. In Charleston, for instance, what they're buildings that are over 300 years old, right? So it's you can't just like tear something like that down because it's not safe for an earthquake. The city of Charleston, the communities, they won't have it. So the challenge is to identify potentially vulnerable structures and come up with a reasonable plan based on the expected levels of earthquake shaking, recurrence intervals, and things like that. And Dr. Jaume is closely in tune with that as well. But so I think that's something that they're that starting right now, they're really looking at that, and how can we catalog that, and what can be done about it.
Fantastic. I think we have questions we have time for a few more questions. Bruce, do you have any questions?
Yes. The question I have, and this would be for Brian, has to do with earthquakes versus hurricanes. It seems to me hurricanes have been mentioned as being a very significant hazard for South Carolina. Being that we have this swarm, do people become complacent? Because we've had a lot of earthquakes, but they don't amount to anything. And compared to hurricanes, these things are not really important. So my question is this, with regard to earthquakes and hurricanes, is earthquakes an orphan or not considered as important by the population in general?
Yeah, I would say it can be a hard sell sometimes when you're not having particularly damaging earthquakes. It's been in the central U.S. We've had some damaging earthquakes. There was the 2011 Mineral, Virginia earthquake that was in central Virginia, did damage in Washington, D.C., and even damaged a building in our church facility in Charleston. But also, they're like different than California. There aren't these very large earthquakes that happen every 25 or in between years. So it can be hard to keep that presence of mind. In the central and eastern U.S., Dr. Jamais may have some more comments on that within South Carolina specifically.
You're on mute.
Oh,
so I got it. Oh, can I add a little bit more to it?
Yeah, please.
Well, just specifically to Charleston, besides hurricanes, so we're right on the coast, even though we're the largest previous recorded earthquake on the east coast of the U.S. Hurricanes are more in the forefront of public perception because we at least get one close by almost every year, right? Like I say, we often get a drive-by hurricanes, even if they don't make a direct impact. But another thing on top of it, which is becoming more and more important as time goes on the coast, is sea level rise, right? We have regular occurrence of blue sky tidal flooding, right, at high tides. Going from when I got here, it may have occurred a half dozen times a year. It's now occurring 10 or 20 times a year. So there's a lot of competing hazards, right, that tend to push earthquakes down the list a bit. But people are aware of it, right? Certainly the folks in emergency management here in the Low Country are very aware. College of Charleston is aware. I'm actually sitting in a earthquake-resistant steel frame building. So the new Science Center that was built specifically to impart house, the geology department and chemistry was built to a high level of seismic design. The County of Charleston a few years ago moved into a new emergency operations center. That's where you were earlier this year, Brian. That is built to a high level of earthquake design. So it is in the consciousness, but it's still not quite up there with some of these more immediate threats.
Okay, thank you very much. Vulcan, do you have another question?
Yes, there's a follow-up about the 0.3G shaking and the questions about whether or not site amplification would be a factor. Is that a soft soil area where the station is?
I don't know if anyone's actually looked closely at the basically shallow shear wave velocities. I know from the Geologic Survey people, there's about 50 meters of Cretaceous coastal plain sediment. So there could be some site amplification, but I don't know enough personally about the geology there to say how significant it is.
Great. We would like to also acknowledge the funding from FEMA for these programs and for EERI. And to acknowledge these, I would like to have first thank our speakers for the great presentations, very short notice, and very beautifully presented their findings. And we would like to, I would like to have Elizabeth talk about EERI's funding arrangement with the FEMA.
Great. Well, I just want to thank everyone again for attending the webinar and also ask you to please complete the post-webinar survey, which you'll receive by email. This helps us design our webinar programming to better meet your interests. You can learn more about EERI at our website, and that's where you can also join and become a member. And to find out more about upcoming webinars, including quick break briefings, but also other ones, you can check out our newsletter, The Pulse, at that URL. And then finally, yes, I just wanted to say that these webinars and events that we do are made possible both by EERI members and their generosity, but also by a grant from FEMA. We want to acknowledge that and appreciate it. So thank you again for attending this Quick Quake webinar. We look forward to seeing you all next time.